Okay, we're going to be graphing absolute value equations. And so we're going to do this a little bit differently than we did at the beginning of the year. Not too much, but just a little bit differently, because we're going to look at the form, because each graph has kind of an easier way to graph that without doing a table of values or anything like that. So my first graph here, it says vertex form an absolute value. I'm going to give you kind of a rough vertex form. This is missing something, but so you have f of x is equal to a times x minus h plus k. Now, we are familiar with this. We kind of knew that this is what, so our a here is what we'd multiply it by, and then our h and k, that's where we'd move it left or right, and we know h was to the right and k was to the left. Okay, so absolute value equations, they have what's called a vertex. That's where the graph changes direction. This is the vertex here. So h and k actually represent the vertex of your parabola. So this one right here, well, how many spaces to the right and to the left would it be if we were talking about our parent function? H and k would be 0, 0. Okay, so h and k represent the represents the vertex of your parabola, absolute value. And a right here, well, the higher a is, you'll notice that the steeper your side is. And essentially what an absolute value function is it's two lines. And the steepness of each side is actually the slope. And so a actually happens to be just the slope of the right-hand side of your graph. Okay, so I'm going to show you how to graph two ways. The first way, I'm not going to necessarily recommend it. But, you know, I'm going to go through this anyway, because some of you guys are wondering how these work, where these numbers actually come from. So what a graph is it's all the solutions to an equation. So for this one right here, we have 2 times the absolute value of x plus 3 minus 1. Now, I know the vertex of this graph. Well, my graph would have been moved 3 spaces to the left, so that point at 0, 0 would be minus 3. And 1 space down. So that's going to be the vertex. So I'm going to put in my little table of values here, I'm going to put negative 3. That's going to be my middle value. Now I need a point to the left and I need a point to the right to actually get my full graph. Now I'm going to show you how this works a little bit. So this is an input-output table. So when I put negative 3 in for x, I should get negative 1 for y. So this is going to be 2 times negative 3. I'm substituting negative 3 in for x here, plus 3 minus 1, 2 times the absolute value of 0 minus 1. So that's going to be 0 minus 1 is negative 1. So sure enough, when I put negative 3 in for x, I get negative 1 for y. That's my vertex. You guys don't have to do this, but I'm just telling you that that's how I come up with the points. I find an x value, I put it into the equation, and then the y value of my point is going to be the output of that equation. So I pick a point to the right. So this is going to be, a point to the right would be, my x value would be negative 2. I plug that into the original equation. Again, I'm going to replace x here. So that's going to be 2 times negative 2 plus 3 minus 1. 2, negative 2 plus 3 is 1 minus 1. And 2 minus 1 is equal to 1. So when I input negative 2 into my equation, I get 1 out. Okay, then I pick a point or an x value to the left. It's usually just 1 less than that, so I pick 1. So I did plus 1 here, and then I did minus 1 here. Because your absolute value kind of has that V shape, we need to get both sides of the V to kind of see where it is. So I substituted in 2 times negative 4 plus 3 minus 1. 2, negative 4 plus 3 is negative 1 minus 1. The absolute value of negative 1 is 1, which is going to be 1 here. Okay, so I plot my points. So my first point, my vertex, is negative 3, negative 1. Then I have negative 2, positive 1. And I have negative 4, positive 1. And so this is what my graph would look like. Okay, and that's if you decide to do the table of values. Actually, any function that you pick, a table of values will work. You can always throw a value in for x, figure out for y, and you can figure out points in the shape of a graph. So for the next thing, the next thing I actually wanted to talk to you about is actually this side right here. Now, if you remember anything about slope, and I'm hoping you remember a little bit, okay, for this side of my graph, I would go right 1 and up 2. So the slope of my right-hand side would be 2, because remember it's your change in y, over your change in x would be 1, would be 2 over 1. Well, where else do I see that? I see that 2 right here. This is always going to be the slope of the right-hand side. So instead of going through and doing the table values and all of that, I do have an easier way, or we have an easier way to do it. We're actually going to be finding or graphing using slope. So the first two things that you have to identify are going to be the vertex. In this case, it's going to be, well, remember this is right 4, up 2. And the slope, RS stands for right side. The slope of my right-hand side is 2 over 3. That tells me that to get from one point to the next on my graph on the right-hand side, so if I'm going to the right, it's going to be 3 right and 2 up. Okay? And we'll talk about the left-hand side. So this is going to be 1, 2, 3, 4, and then up 2. That's my vertex. Okay? Then the next thing it says is I'm going to graph the right side of my graph. So I'm going to go 3 right, 1, 2, 3, and up 2. And then I could do it again. I could go 3 right and up 2. All right. Now the left-hand side of your graph, you're just always going to be, instead of going right, this is actually for the left side, it's going to be 2 up, but instead of 3 right, it's going to be 3 left. And so I'm going to go 2 up and 3 left. And you can check this in Desmos. You can just graph it, but this is exactly what it looks like. And I actually do need to see these points. I need at least 3 points. Otherwise, I'm not going to give you credit on your graphs. So again, 2 up, 3 right, or 2 up and 3 left. So we'll try this again with the next one. So my vertex in this case, it's 1 left. And I don't have anything over here, so that's actually going to be a 0. So my vertex is at -1, 0. And the slope of my right-hand side, you always put the negative with the top. Okay, and the reason why you have your negative on top is because the slope that's here, this number right here, is always going to be the right-hand side. So again, you're going to, for this, you're going to be going down. Okay, so this is going to be -4 over 5. This just means 4 down. So to get the right-hand side of my graph, I'm going to go 4 down and 5 right. For the left-hand side of my graph, and that's why I'm writing LS, it's going to still be 4 down, but instead of going 5 right, I'm going to go 5 left. It's just instructions. That's all it is. So first thing I do is I graph -1, 0. And to get to my right-hand side, I'm going to go 4 down and 1, 2, 3, 4, 5 over. And then I'm going to go 4 down, 1, 2, 3, 4. And then I'm going to go 5 left. So on my right-hand side, I went 4 down and 5 right. Okay, to my left-hand side, I'm going to go 4 down and I'm going to go 5, 1, 2, 3, 4, 5 left. And there you go. Hopefully your hand is steadier than mine. Okay. So we're going to go from here. We're going to talk about graphing absolute value inequalities. These aren't so bad. It's just, you just have to remember a couple of things, but you've graphed inequalities before. You graphed a line right here and you said, okay, if I shaded above, it was greater than, and then you also had your dotted line, and if you shade below, it was less than. Okay, maybe you guys remember that from Algebra 1, but at some point you did graph inequalities. The rules don't change much when it comes to that here. So you're going to do the same thing that we just did, plot the points on the function, the vertex and slope. Okay, you're going to graph a solid line if it is equal to, okay, so it could be greater than or equal to or less than or equal to, you're going to have a solid line. Your line is going to be dotted if it is not or equal to, Okay, so it could be less than or it could be greater than, but as long as it's not an or equal to sign. You're also going to have to worry about shading. You're going to shade your graph above. Okay, you're going to shade above your graph if it is greater than or equal to. You're going to do below if your graph is less than or equal to. Okay, so like I said, not much is going to change with these inequalities. Okay, my vertex for this one, well, there's no shift on the inside, so that's going to be 0, and then up 1. And my right-hand slope, there's no number here, so if there's no number, you put a 1 there. So my right-hand slope is going to be 1. And if you're wondering, okay, if you have a whole number like this, it's actually going to be, or it could be 1 over 1. That's my slope. Okay, so my vertex is 0, 1. Okay, and then my slope for my right side is going to be up 1, right 1. So up 1, right 1, up 1, right 1, up 1, right 1. Okay, and for my left side, I'm still going to go up 1, but remember, instead of right, you're going to go left. So this is going to be left 1. So up 1, left 1, up 1, left 1, up 1, left 1. Okay, so now what we have to look at is we have 2 more things to do with it. The first thing you determine is this right here. Okay, this is going to be dotted because it is not equal to. So when I graph my line, I'm not going to make it a solid line. Okay, and I'll explain that in just a bit. Okay, the next thing is my graph is less than. So this is less than, which means you're going to shade down. So for this, I'm going to shade below my graph. So if it's less than, I'm going to shade down. And there you go. One of the things that I ask you to do is to pick a point and substitute into the equation to see if it works. So if I did this right, if I graphed this right, this point right here, because it's in the shaded part, should actually work in my original problem. So the coordinates of this point are 3, 1. So I substitute 3, 1 in. So I substitute 1 in for y and 3 in for x into my original problem. So my f of x or my y is 1, and this is going to be 3. So this is 1 is less than the absolute value of 3 is 3. 1 is less than 4. That's true, so that checks out. Now here's the next thing, and I just want to go through this really quickly, is what if I pick a point on the graph? Well, let me pick a point on the graph. That point right there is 1, 2. Okay, I substitute in. I substitute 2 in for f of x is less than, and then I substitute 1 in for y. So this ends up being 2 is less than 1 plus 1, 2 is less than 2. Is 2 less than 2? Well, that's going to be a no, okay? That point would not work because this is not a true statement, okay? And that's why this is dotted here means that any point on that line is not going to work. All right, so let's try this one more time. Okay, so my vertex for this one, we have 2, it's minus 2, so remember it goes 2 to the right, and up 3, that's positive 3. My right-hand slope is negative 4, or we write this as a fraction, negative 4 over 1. Okay, so the first thing I do is I plot my vertex, so that's going to be 2, 3. And then I look at my slope. My slope is negative 4 over 1. So that means it's going to be, for the right-hand side, it's going to be down 4, right 1. So I go down 1, 2, 3, 4, right 1. Okay. For the left side, it's still going to be down 4, but instead of going right 1, we're going to go left 1. So we're going to go down 1, 2, 3, 4, and left 1. Okay. I could do it again. Down 4, left 1, down 4, right 1. Okay, now I go back up to the top. Sparkly pen time. This right here, because it's or equal to, my line is going to be solid. Okay, so I have a solid line here. I don't think the sparkly pen does a really good job of making it so the line is solid. So let's just go through and just kind of do this. There we go. We have our solid line. Okay, now the other thing is we have to figure out shading. Well, our shading is it's greater than, so you're going to shade up. And so I'm going to shade all above my graph. Happy little shading. Okay. All right, and so last thing I'm going to do is I'm going to do the check for this. So for the check, I plug a value in. So I pick a point, any point. I'm just going to pick, let's say 0, 0. Okay, because 0, 0 is in my shaded region. So I'm going to plug in 0 in for f of x. So that's going to be 0 is greater than -4 times 0 minus 2 plus 3. 0 is greater than or equal to -4, absolute value of -2 plus 3. 0 is greater than or equal to -4 times 2 plus 2. 0 is greater than -8 plus 2. 0 is 0 greater than -6. Well, yeah, it is greater than -6. So it does check out in our problem. And so there we go. That's what I mean by checking a point. All right. So let's go, and what we're going to do is going to find the equation. I'll fix this part in post. So find the equation from the function. So you go through, you identify the vertex. So I'm just going to go through all of these. So identify the vertex, that's the first thing. So my vertex right here is at -3, 2. So I know my vertex is at -3, 2. So when I write my equation, it could be y is or f of x is equal to, I'm not sure what this number is right here yet, but I know it's going to be x plus 3. Remember, it's 3 to the left, and so it's going to be plus 3 plus 2. Okay, the next thing is identify the slope. I shouldn't write that as equal to, it just should be blank right here. We'll talk about that in just a second. I apologize for that. Okay, so it's going to be y is something to something, something, something. Okay, identify the slope of the right side. So how do I get from one point to the next? So from here I go 1, 2, 3, 4. Well, let me pick a point. So sorry, to get to this point right here, let's say we go 1, 2, 3, 3 over and up 1. So 1, 2, 3 to the right and up 1 to get to from one point to the next on the graph. So my slope, my right side slope, is going to be 3 over 1. What I was trying to show you, not very successfully, so I'm sorry about that, is what if I pick this point over here? Well, that would be right 1, 2, 3, 4, 5, 6, right 6, and up 2. And you're like, Miss Holly, that's the same thing, or that's something different. Well, 6 over 2 is actually the same thing as 3 over 1. So it doesn't make a difference. Just make sure that you simplify your fraction, whatever you get, to get from one point to the next. So my slope is going to be, so this number right here, my a value is going to be 3 over 1, or just plain old 3. Now the next thing you have to figure out is identify the inequality. Is it equal to or not equal to? Well, it's dotted, so it's going to be not equal to. Okay, and then the next thing is if it's shaded above the graph, it is greater than or greater than or greater than, okay, or greater than or equal to. And if it's shaded below the graph, it's less than or equal to. This is shaded above the graph, and so therefore this is going to be greater than, and it's dotted. And I know this is going to be confusing, so I'm just going to get rid of that dash mark. So it's going to be y is greater than 3 over 1. Okay, or just plain old 3, x plus 3 plus 2. So either of these are fine. All right, last one, and I'm sorry, this has just been a struggle today. Okay, so first thing you do, identify your vertex. My vertex is 0, -1. My slope of my right side, well, I have to pick another point, so I'm just going to pick this point right here. So it's down 1, 2, 3, 4, and over 1. So my right side slope is down 4 right, 1. Okay. The next thing I look at is I look at my line. It's or equal to. And I know with the shading, it's down, or it's actually below, so it's going to be less than. And I just write that out. So I know it's going to be in the parentheses. It's just going to be plain old x. Some of you might have like x minus 0. That's okay. Okay, but since it's, and then I know it's going to be minus 1 on the outside because that's where my vertex is. My right-hand slope is going to be negative 4 or negative 4 over 1. My graph, it's solid, so it's going to be or equal to, and it's shaded below, so it's less than, so it's going to be less than or equal to. So y is less than or equal to negative 4 times the absolute value of x minus